Let's do section 11.1, page 542, exercise 29, which reads, find the length of the curve. For exercise 21, our parametric function is x equals 8 cosine t plus 8t sine t, y equals 8 sine t minus 8t cosine t, and we're looking at the interval from 0 to pi over 2 for t. So I think it's always a good idea to start off by graphing. So if we look at this, we get something that looks like this, where this point here is x equals 8. And it's kind of your regular run-of-the-mill kind of curve. So the section tells us that we can rewrite our length formula from chapter 8 as this when we have parametric equations. So we're going to have L is equal to the integral from t1 to t2 of the square root of dx dt squared plus dy dt squared all times dt. So the first thing we need to do is take our derivatives. So let's start by taking dx dt, and we're going to have negative 8 sine t, and then we're going to have to use our product rule, and so we're going to have 8 sine t plus 8t cosine t. And of course, our 8 sine t's are going to cancel, and we're going to end up with dx dt is going to be 8t cosine t. And now I'm ready to take my y derivative. So I'm going to have dy dt is going to be equal to 8 cosine t minus, and again I'm going to have to use the product rule, so I'm going to have 8 times cosine t plus 8t times negative sine t. And again, my 8 cosine t's are going to cancel, and I'm going to be left with dy dt is going to be 8t sine t. And now we're ready to substitute into our length formula. So the length is going to be equal to the integral from 0 to pi over 2 of the square root of dx dt squared. So that's going to be 8t times cosine t squared, the whole thing squared, plus dy dt squared. So that's going to be 8t sine t squared, all times dt. And we want to continue by evaluating those squareds. So we're going to have the integral from 0 to pi over 2 of the square root of 64t squared times cosine squared t plus 64t squared times sine squared t, all times dt. And then I can factor out the 64t squared that's in every term. So I'm going to have the integral from 0 to pi over 2 of the square root of 64t squared times cosine squared t plus sine squared t times dt. And we all know that cosine squared t plus sine squared t is going to be equal to 1, everybody's favorite trig identity. So this is going to give me the integral from 0 to pi over 2. And this 64t squared is a perfect square, so I could take the square root of it, and I'm going to end up with 8t dt. And that is something that we can easily find the antiderivative of. So L is going to be equal to 8 times t squared over 2 evaluated from 0 to pi over 2. Of course, my 8 and my 2 are going to cancel and give me a 4. And then I'm ready to substitute in my limits of integration. So this is going to give me pi squared over 4 minus 0, or the length of my curve is going to be pi squared.